Good morning, everybody. Happy Sunday. So glad to see you here. Hope that you're doing well. Hope that you and your families are safe in your part of the world. And it is a beautiful day out where I live. Really nice Sunday. Really looking forward to doing the stream with you. And then, as you guys know, I always make my soup on Sundays. So I'm going to do this stream and then go eat, have my soup, relax, watch some TV or something, and just enjoy the rest of my day. But really, the best part of my day is being able to be here with all of you, sharing our time together, share in the knowledge and the community that is data science. So really looking forward to all of us spending time together. And as most of you know, on Sundays is when we do our little bit of our longer tutorial session. So today we're going to be continuing our session on creating a data science project from scratch. I am in awe. I am in complete awe that we are now on part 6. Oh my gosh. How did we get here, guys? The last time I think we did the series on the Introduction to Statistical Learning book, it was 8 parts, I believe. I think it was 8 parts. So we're already approaching that. We're probably going to go over 8 parts, almost certainly going to go over 8 parts. So really crazy that we're already at part 6. That is crazy, guys. So good job to everyone who's come from the beginning. If you're new, that's okay. You might have to catch up a little, but I know a lot of you only come on Sundays because you enjoy the tutorials. So good job to everyone who's been here from the beginning. I think we're going to have another great session today. So really looking forward to spending the next few hours with you. And I say that because we do tend to go long on Sundays. We've gone up to 3 hours before. So I start my soup accordingly. I cook my soup in a slow cooker. So I think we're going to have a really good stream today. All right. So I'm already seeing some people popping into the chat, which is great. If it's your first time, don't be afraid to say hello. My channel is really growing across most platforms, certainly on YouTube and definitely on Instagram. But I'm also getting people on Twitch, people on Kick, on LinkedIn. So don't be afraid to say hello, or, just kind of, let us know what you're up to. No one's going to call on you. You don't have to ask some amazing question to participate. I'm really just trying to create the community here. But yeah, today's Sunday is going to be all about the tutorial. So I'm going to, look at the chat. Feel free to say hello. And then after we do that, we're going to go ahead and get started on the lesson for today. So let me start looking. From the very top, I'm seeing Mustafa over on Twitch. Thanks so much, Mustafa. I'm pretty sure it's your first time here. So thank you so much for stopping by. I hope that you're doing well, and glad you're joining us on Twitch. Guys, I have a lot of followers on Twitch, more than I ever thought possible. And they do join, but Twitch is definitely more of an evening platform. So I think I might do some more evening streams on Twitch. I'm not sure. But always nice to see the support on Twitch. So thanks so much for that. Manoj, our good friend Manoj. Good morning, Sir Dennis. And good morning, Sir Dennis and everyone. Manoj from Bangalore, India. Manoj, so glad you're here. Hope you're doing well. You've been a big part of this series. So really looking forward to finishing out the series with you in the future. And, we'll see where it goes. So thanks for being here, Manoj. Hope you're well. Javed, I think it's your first time. Sorry, I don't know what that message means. If you want to, translate that for us, I'd appreciate that. Or maybe somebody can tell me if that's spam. I don't know if that's a spam message. Starry Vibes, good morning. How are you? Hope that you're doing well. Hope that you and your family are well. Osama, our good friend from Satat, says, hello, sir. I hope everything is going well. Everything is going really well. It's Sunday. We all get together and talk about data science. So can't be a bad day, right? Can't be a bad day if that's the case, right? But yeah, everything is going really well. Since the stream yesterday, I did, I went out for a good walk with my dog. We had a good time. We went to the park, got back home, had some lunch, spoke with my parents. And yeah, just looking forward to continuing my weekend and having a good time. I've been up this morning since 3 a.m. I was doing some work. I was doing some client planning. I was doing some advertising planning. I basically queue up all of my posts ahead of time so that the advertisements can go out. I'm coming up on 100K, on 100,000 followers on YouTube. So I was doing some planning for that. I'm looking for a sponsor for that stream. That's probably going to be a 12-hour stream. So looking forward to that. But yeah, just doing all kinds of stuff, Osama. I get up early and I start working right away, and really excited about being able to share 100,000 followers coming up on YouTube with all of you. So yeah, lots of stuff coming up. And then I'm also preparing for January. As I've told you guys, in January, I'm going to be bringing you guys a lot of different content. So preparing for that. Just getting a lot of things ready, Osama, but it's been a good day. Rex, one of my great moderators, says from a chilly Sunday morning in New York City. Good morning, everyone. Yeah, good morning to you too, Rex. And as I told the chat before, the fall time in New York, even though it's chilly, beautiful time to be in New York. I'm jealous, Rex. All right. And Rex, thanks so much for playing host over there on Twitch. Joseph, good to see you back. I think yesterday was your first day and today you're coming back. I love that. I love seeing people coming back. Joseph says, hello, Dennis. Joseph from Paris. Hope you're doing well out there in Paris. Like I said, I love seeing people back. Joseph, today is going to be a little bit different because yesterday you saw more of our conversational type of streams. But today we're going to be doing more of our tutorial streams. So it's a little more instructional. I put more things up on the screen. I ask for more interaction. So really glad you're here, and you're going to see a whole different side of kind of like the streams that I do. So hope you enjoy it, Joseph. But thanks for being here. I hope you're well. All right, so I don't usually answer questions on Sundays, but since Mustafa is new, I'm going to look at this. Sir, I had a question. I'm a computer science student in my 3rd semester. I struggle with solving problems, like I know about the concept, but struggle implementing it. How do I improve my problem solving skills? And Mustafa says, thank you. Okay. Help me understand this. 3rd semester, so that's the beginning of your 2nd year, I think, right? I'm assuming it's like a 4-year program, and 3rd semester will be the beginning of your 2nd year. Let me know. Let me know if I'm wrong on that. But look, 2 things come to mind. One, it's very early, right? Don't get frustrated. You're still very early in your studies, right? 3rd semester is not far into your studies, right? I'm assuming you have 8 semesters? So don't worry about that. Give yourself, take some of that pressure off, right? Because you still need to gain more knowledge before you can really understand the concepts, right? So that's the first thing, right? Take a deep breath. Give yourself some liberty to say, hey, I'm still learning. I'm still in the process, right? Totally okay to do that. And then the second thing that comes to mind is when it comes to implementing concepts, it's not just one thing, right? It could be a variety of things. It could be things, oh my gosh. Yes, it's a 4-year program and I'm learning C++. Oh. Ooh. What are you doing to yourself, my friend? Oh my God, I think I'd kill myself if I had 4 years of C++. Oh. All right. All right. All jokes aside, right? C++ is hard, right? There's no other way to say that. So take some of that pressure off. You probably just don't know enough about C++ or, object-oriented programming at this point to help you really understand those concepts. So if you're struggling, you're probably not the only one, right? And by the way, guys, obviously what I'm saying also goes for data science, right? 3 semesters of data science is not a lot either, right? So take some of that pressure off, give yourself some liberty to say, hey, I'm still learning, right? But as far as the next steps, are you lacking creativity? Are you lacking motivation? Are you lacking the drive to learn more, right? It could be all of those things, right? It could be a combination of all of those things. So I would try to take some like a self-survey and figure out what is it about your current course of studies that don't have you feeling so great, right? So take the time for that self-reflection to figure out what is it that you need to hone on. What is it that you need? Like, do you need more creativity? Are you just not excited by C++ or something else, right? But that's what I would do, Mustafa. Just give yourself the opportunity to keep on learning, and give yourself the self-reflection to say, well, why am I not applying these concepts? Mustafa says that's true, but I don't get good grades in computing subjects. Okay, well, that could be a whole other situation, right? Because that could be you as like an interest or like a mental challenge that you're having. But then that could also be personal, right? Like, are you disorganized? Do you go out too much? Do you drink too much? Whatever, right? So I'd have to have a lot more information to help you specifically in that, right? Because there could be a lot of reasons. Getting good grades and being interested in a topic, two separate things, right? Like, I had the opposite problem. I was interested in a ton of topics that I got terrible grades in, right? Like, I hated my high school. I went to the world's worst high school. So, but I was still interested in the topics. Academically, I didn't do terrible, but I didn't do fantastic either, right? But the subjects themselves still interested me, right? So what does that look like for you? I'm just giving you my view, but that looks different for everybody. And that could have an effect on whether you're getting good grades or not, right? So, all right, guys. So Mustafa, love that you're here. Welcome to stay with us. But I think that's, if you want to come back for more specific help, I'm going to ask you to come back during one of my regular streams where I do more of the questions and answering. Because like I said, on Sundays, I usually do more of the tutorial side. Okay. That's what I try to focus on. So I just realized I forgot to start my Instagram side. So sorry guys, let me get my Instagram side going, and we're going to start on a tutorial. But if anybody else wants to introduce themselves, feel free to do that in the chat. And give me just a second, guys. I want to send the widescreen view to my people on Instagram, so that way everybody can see the presentation a little bit better. All right. Khalif, our good friend Khalif, greetings of the day, sir. Everyone, the same here. I'm interested in the subjects, but grades aren't my goal. Yeah. Okay, so Khalif, I appreciate you, giving your opinion on that topic, even though, it's not really today's topic, but yeah, sometimes guys say, and I hope you all, I know you all realize that what I'm talking about applies to data science too, right? If you're inherently interested in the topic and there's parts of the field that interest you, then keep going, right? Obviously, try to get the best grades you can, but don't let grades kind of discourage you from saying, oh, I'm not a very good data scientist, or maybe this isn't for me, or whatever, right? If you're still inherently interested and the reasons why you started in that field to begin with are still there, then don't stop, right? Keep going. Don't let the grades and stuff kind of bog you down, or also in some ways, they can do the opposite effect. Well, they'll really excite you about it because, you're taking easier classes and you're getting good grades, but maybe your actual practice, your methodology with data science isn't that great, right? So try to separate those two. But if you're still interested in the topic, keep going. Keep doing your best. Denelson, our good friend Denelson says, good morning, everyone. Hope everyone is staying safe this weekend. Thank you, Denelson. I think we are. I think we're all having a pretty good weekend. So thanks for being here. Hope you're well. All right. So anybody else wants to introduce himself? I'll keep an eye on the chat. I have my Instagram chat up and running for people who want to join there. But on Instagram, I have also put in the link to the widescreen, which is a little bit better for Sundays. But I'm ready to get started. I hope you guys are too. Let me refresh this. All right. Lakshmi, our good friend Lakshmi says, good morning, Dennis and all. Hope everyone is doing good. I think we're doing very good, Lakshmi. Hope the same for you. I know you're a big fan of the Sunday series, so glad to see you here. Glad that you're back. And hope that you're well in your part of the world. You came in just in time as I have my my classroom view up. Okay, I think that's everything I needed. Let me make sure I have my code and stuff up. Yep. In my console. Yep. Okay. Excuse me. I'm having a hard time believing that this is part 6. This is crazy, guys. We've made a lot of progress in this series. So we're going to continue on creating our project. In the chat, I'm seeing a lot of the people who have contributed to this project previously. So I'm really glad that they're here because we're going to do the same thing as we did before. We're going to continue the back and forth. We're going to continue the ideas flowing, right? We're going to continue talking this out, simulating that environment where I've told you before, we are the data science team sitting in the team room, talking things out. Right? We're going to sit here and we're going to toss around ideas, explore some ideas, do some code, look at some visualizations, and really just try to help us keep on focusing our efforts towards coming to a model that ultimately serves the needs of our client. Right? That's kind of that's still the remaining goal here for this session. So let me start going. This is section 8 of the slides. And we're going to continue with the technical touch point, right? And this is the second time we're doing the technical touch point. And as I mentioned to you last time, as a quick review, these technical touch points is basically how I run my data science team. I mean, obviously I have conversations with people throughout the week and phone calls and, Teams messaging or stuff like that. But I run them every week. I'm the highest manager in the room. No one and nothing gets spoken above me, right? I don't go tell my boss what you told me in the meeting. And then nothing that is said in the room is ever said again, right? So we want people here to be honest. We want people to ask questions. We want people to not be embarrassed about the questions or thoughts that they have, right? Nothing is a bad question. Nothing is a bad answer. It's all about the conversation because that's what leads to a better scientific process. And if we have a better scientific process, we will ultimately have a better model. And that's the goal, right? So that's the kind of environment that we're going to continue today in our discussion. So as a reminder, the whole point of the touch point meetings is, what have we accomplished? What do we need to do this week? Are there any roadblocks that need to be addressed? Or maybe not in an immediate week, but are maybe coming up down the road. And then what do you need from me as the chief data scientist, as the data executive in the room? What is it that you need from me in order to keep moving forward, or any decisions that need to be made or things along those lines, right? So starting with that first one, what have we accomplished? Well, we went through a session where we set up our client contract, right? Our statement of work. And we know that statement of work is about creating an algorithm for alpha farming for a finance company. Right? We did some agile planning, right? We had an entire session on agile planning. We had another session where we just talked about ideas, possibilities, different things that we could be doing, right? That was an entire session that we did. And then we also, within that session, we tossed around things like the new sentiment analysis, the efficient frontier simulations, and then we also talked about time series forecasting, right? And then within all of that, I mentioned to you how sometimes when you toss around ideas, you still need to go through a process to examine them. Just because you have an idea doesn't mean that you should go like full bore on it, right? Like, yeah, go build that model. Sometimes you need to explore things. Do we have a library for that? Do we have the data for that? What does the data pipeline look for that? Are we going to have to pay for the data? Are there going to be incurred costs? What about the size of the models? Maybe we should scope out the size of the model. Does that make sense for the different things that we want to do, right? So those are the two ideas that we have basically, or excuse me, that's the whole point of kind of having that ideation process. It's not to make decisions. It's to be able to say, hey, this might have some possibilities that we should be looking for, right? So that's essentially what we've done here. And we've done that with two ideas, right? We have scoped out the new sentiment analysis. And then last week, we spent some time scoping out the time series forecasting, right? We still have this third idea of the efficient frontier simulations that we might spend time on today. We might not. It depends. You guys are going to help me set the agenda for today. But the whole point is that this is the work that a data science team goes through. This is what you do in the team rooms, away from the clients, away from everybody else. Right here is the heart of the work of a data science team. So that's what we're going to continue, right? So today's session is all of us meeting in the data science team room and working on some ideas, scoping some things out, maybe making decisions, maybe not, but we're always going to be following a methodology. Our guiding light is always the scientific method. And by doing that, we're living the lesson that I tell you guys, that data science is not Python, it's not an algorithm, it's a process. So we're just going to keep on continuing down our process and hopefully getting to a better place, right? All right. So I think I put this one in by mistake. Sorry, that's an extra slide. Okay. So one of the things I do want to give you a disclaimer on is that some of the upcoming items and some of the items that we have done, you're going to be doing to a much greater depth, right? It's usually not just one session. But I have to do that because, I want to keep the series moving, right? We got a lot of things to teach and cover, right? So for the purposes of seeing the entire life cycle, I'm going to have to move some things along. We're probably going to make decisions a little bit faster than what you would usually do in a team situation, right? So I do kind of want to give you guys that perspective that in some cases I am kind of, moving things a little faster than what we would. But, that's just for the purposes of, this being a live stream and all of that, right? But I want you to keep that in mind. All right. So section 9 is what do we need to do this week, right? We just looked at the past. We just took a quick review, right? So if you remember nothing else from this session, please remember this chart, because this chart is really what guides us. Right? This chart is the methodology. And when I'm referring to a process, this is what I'm referring to, right? The methodology of data science. So first chance for participation. I know some of you have been here for every session. So I want you to kind of tell me what section of the visualization do you think we're at right now? Are there any that you're uncomfortable with? Are there any that you think need to be redone? But if you look at this map, right, and this roadmap, supposed to go, data collection, enrichment, visualization, ideation, model design, right? You can see the path, right? Where do you guys think we're at? There's no wrong answers. It's good to see people's perspective, because some of you might say, well, no, wow, we're still at data collection. Some of you might be ready to interpret results. So please, in the chat, I'll give you guys a minute here. Where do you think we're at? If we agree that this is our methodology, this is our process, where do you guys think we are in the process? No wrong answers. Just give me your perspective. Lakshmi says, I'm doing good too. It's dinner time here, so just done with it and all set for the next few hours. Okay, Lakshmi. Look, Lakshmi, I'm not trying to go 3 hours every time with you guys, right? It just so happens we've done that, but I'm not trying to do that every week, guys. We'll see. We'll see where the discussion leads us. You guys are always great about that. I think it's Urganesh. Urganesh, will AI replace us completely? Urganesh, I appreciate the question, but on Sundays I usually do it more instructional. But thanks for being here. You're welcome to come on any other day and ask those questions, all right? Bikash, welcome. Glad you're here. I think it's your first time, so thanks for joining. All right, so Osama is volunteering his answer already. And guys, go ahead and give your answer. But the question in front of the chat right now is, where do you think we are in the methodology process, right? So Osama is saying that we are at the data enrichment phase. Okay, cool. I like it. I like it. And by the way, you can also just say, hey, I agree with Osama, or I agree with Denelson, whatever you'd like. So Denelson says, I think from last week's section, we need to take a step back into the collection and maybe the ideation. Okay. All right. So I'm hearing that Osama is here at enrichment. Denelson is here at ideation. Maybe even some data collection from Denelson. Manoj is ready to talk model design. Okay. So Manoj is ready for model design. So we kind of have people all over the place, and that's totally okay, right? We're just hearing other people's perspectives right now, and that's a valuable thing. So give you guys another 30 seconds. What do you guys think? Anybody else wanna kind of volunteer where we think we're at? Starry Vibe says we are still in the ideation phase. Okay. All right. So, gosh, we have everybody we have almost one person at every single of the first 5 stages, right? Because we've had people say collection, we've had people say enrichment, ideation, model design. So yeah, that's crazy, guys. Anybody else? Last call for answers. Last call for answers. Or like I said, you can just choose to agree. You can just say, I agree with Starry Vibes, or I agree with Denelson. It's up to you guys. But a good variety of answers, and I think this is a good thing. I'm really happy with that. And by the way, the reason I say that I'm happy with that is because this is one of those things that you're sometimes going to hear to refer to as a diversity of thought, right? This is where you come and say, hey, you know what? There's a value in hearing out people that have different views than you, and that's okay, right? So this is that diversity that we're sharing, and that's a positive thing. So I hope you guys are finding some benefit in that, because it's really a positive thing. Manoj says, agree with Osama if data or our EDA does not have enough evidence. Ooh. Osama is advocating for data enrichment though, right? Right, Manoj? And Manoj, you were advocating for model design. So that's an interesting section, right? Because Manoj, how do you know if you have enough evidence if you haven't actually done some modeling though, right? Like don't it's kind of like that old the chicken and egg issue, right? What came first, the chicken or the egg, right? So Manoj, how do you know you have enough evidence unless you kind of, go down the road a little bit, right? So I don't know, Manoj. I was kind of leaning towards your previous suggestion of the model design. I think that you could make an argument that we're ready for model design. Could you make an argument that we need data enrichment? Yeah, sure. But for which one? Because we're kind of tossing around three different ideas, right? In a way, we're still kind of scoping out all three of those ideas, right? So I don't know. I can see arguments for all of these. Well, look, coming back to the core question, right? My core question was asking you guys what portion of the methodology do you think we're in right now, right? I think that essentially all of you picked very reasonable stages. And more so, you picked reasonable stages based on the idea that we were scoping out. So when we were last looking at new sentiment, we were talking about how some of the stories were not just biased by sentiment, but they were biased by their source, right? Where maybe we were pulling too much from financial information, where we should have been pulling from things like consumer information or consumer-oriented websites, right? So that's a data collection process. And in a way, it's also like a data enrichment process. Because remember on that idea, we had talked about how, okay, well, that's just like a little mini model. That's just a mini model that tells us about the sentiment. But then what are you going to do with that? Well, excuse me. It only tells you about the counts of the sentiments. But what are you going to do with that? Are you going to add those numbers up? Are you going to only take the positives, only take the negatives? Do you drop the neutrals? Do you keep the neutrals? Right? And then where do you feed that into? Right? So that's kind of a enrichment / ideation type of phase still. Right? Now, if you're referring to some of the time series work that we did last week, model design is a valid suggestion there, right? We got pretty far into that, into exploring meta, exploring profit by meta, right? There's an argument to be made that, hey, maybe we're ready for that. We were looking at visualizations last week, but to move that further along, we need to be able to look at things programmatically, right? It's not efficient for us to build a model if we have to examine every single chart, right? So there's something to be said for that, for looking at model design. So I think that we can touch upon all of those today during today's session, right? We can look at the model design for the time series. We can keep on talking about the sentiment analysis, kind of see where that ends up, right? Because again, we don't have an answer to that mini model type of approach. And I think it's an important question. And then what I really like to start off with today is we have this third idea, right? Let me go back to the slide. We have this third idea of the efficient frontier simulations. We haven't really spent a lot of time talking about that one, right? But it's worth scoping out. It's worth it to be able to go back to the team, again, just the data science team, not the client, and be able to say, well, look, these are the three different ideas that we're considering. Let's start making some decisions. Let's start choosing the direction that we actually want to go in. right? So I think that there is some value there for us to be able to bring in a third idea and then start making some decisions on where we're going to go with this. Because I think we've seen enough from time series and news sentiment to kind of see how that's shaping up, still have a couple of questions, right? But overall, I think that's where I'd like to go today, because I think that's where I see us being, where we still haven't done a lot of work on this idea, and then let's come back together with 3 ideas, and then we'll pick a specific direction for us to go in. All right, everybody good with that? Let me know in the chat. But that's what I'd like to do today, which means that we're still going to be continuing our AI first attitude, and we're going to be relying on our employee, ChatGPT, to help us with, with work, right? So let's start off. So somebody correct me in the chat, but I believe that the efficient frontier was a suggestion that was made by Manoj. So Manoj, I might be relying on you for some help here, because I am not familiar with the efficient frontier theorem or the approach, right? And that's okay, right? I don't have to know everything, but I do have to have the people around me to help, right? So collaboratively, we're going to work on this. And in a roundabout way, I'm also going to have a little bit of a lesson to attach to it, I think, right? I'm kind of making my own assumptions there. But we'll get to that point, okay? Lakshmi says, that sounds good. They'll have no idea about our efficient frontier. You know, Lakshmi, I appreciate your honesty, because, you have to know what you don't know, right? So yeah, Lakshmi, I'm in the same boat as you. I don't know a lot about it, but hey, we don't have to, right? We have an employee. Our employee ChatGPT should know about it, right? Okay, so Manoj says, yes, sir. Yeah, okay, Manoj, I figured it was your idea. So that's what I want to do today, guys, right? So for those of you that are new, because I know we have a couple of new people, professional data science is not done in notebooks. Professional data science is done in Python scripts and programs, right? Because you're going to be working in large distributed environments, and you can't deploy a notebook. So what do I have? I have my Visual Studio Code. We have a couple of files that we downloaded for data, just to kind of scope things out. We have a couple of code files that we have used. ChatGPT has written all of this code. We do not start from a blank screen. We are supposed to be more efficient by using ChatGPT for our coding, and that's our approach. Okay? So, Manoj, I think you gave us some guidance last time about the API that you thought would be useful. I think you said it was the Y Finance API. But let's use ChatGPT, right? ChatGPT is our employee. ChatGPT should help us with that, right? So let's start. If you guys need me to make anything bigger or anything on the screen, let me know. Okay. So Manoj, correct me if I'm wrong, but I think you said that Y Finance has some information on the efficient frontier, right? So can we, do you have any objection if we go ahead and use that? Let's see what Y Finance has in terms of that. So, using. And last week we were focused on Microsoft quite a bit. We were looking at Microsoft and gold. So let's go ahead and keep on doing that, right? We're going to specify what we want and this ticker symbol. Okay. So here's the, you'll need to analyze the efficient frontier of your investments. You'll need historical price data to calculate returns and volatility. Why Finance has that. Historical data for 1 year, going back 1 year per day. That has the data. History method. Okay. So it looks like it's going to give us some collection first. And we'll have to, this is good initial code, but there's no saving function or anything else, right? So we're going to have to be a little bit more specific and say, so remember that with alpha farming, the goal, the value add that we bring is that we're going to be able to look at a lot of different ticker symbols, right? A lot of different investments. That's what's going to help us and be able to say, okay, yeah, not only is our algorithm doing the calculations, but it's doing it so much broader and so much faster than a human could. And then that's part of the win, right? That's part of the benefit that your algorithm is bringing to the company, right? To our client. So we want to make sure that we have the processing, but we also have the width. So that those are the elements that we have in our other scripts that was missing from this particular example. So let's go ahead and copy that code. Let's bring it into Visual Studio so we can see it a little better. Yeah, so let's go ahead and add a new file. And this is going to be EFF collection, right? Because we have our collection files and then we have our processing files, right? So, oh, what did I just do? Did I press escape? I did. So EFF collection. All right. So what do you guys think? This is the code that gave us the data, or that this is the code that ChatGPT gave us. Sorry guys, I have a lot happening on my screen. I'm also looking at AJ's comment here. AJ, welcome. Good to see you again. I think you're from Berlin. I hope you're doing well out there. Well, actually, I skipped over Lakshmi. Lakshmi says, yeah, sure. It's always good to learn something new. It is, right, Lakshmi? So let's see where this leads us. AJ says PyPortfolio Opt is a Python library that implements portfolio optimization methods, including classical efficient frontier techniques. Okay. AJ, was that one of the ones that ChatGPT recommended? I don't remember or not. Bloomberg, Polygon, Morningstar, Quando, Alphabet. It's not. So AJ, one of the tricks that we need is that we also need something that's free, right? Free, doesn't require any registration, any of that nonsense. That doesn't always apply to financial data, right? So if you know the answers to that, please let us know. But I'm pursuing the Why Finance because it's a little bit, it's free, it's easy to implement, right? Along those same lines, Manoj, if you know of a better way, or if you see something going wrong here, let us know, okay? All right. So here's the code that was given to us by ChatGPT. What do you guys think? AJ says it is free. Okay, thank you, AJ. Let's keep going down this road. All right, and we'll see where we end up with it. Well, what do you guys think from this? Manoj says Y Finance is better, but Manoj, help me understand how Y Finance does it, because I'm surprised that there's no individual parameter for it within the API. But we're going with what ChatGPT recommends, right? Because that way we also learn the capabilities of ChatGPT, and we also get to work on our prompting skills. But Manoj, if you see something going wrong, let us know, okay? But what do you guys think about the collection code? It's only 17 lines. It's good for people to have an opinion on code like this. What do you guys think? Anybody see anything wrong or anything like that? AJ says, Y Finance only provides price data, does not provide portfolio optimization algorithms. Yeah, AJ, you're right. And that is where I'm a little skeptical right now, because I thought that Y Finance would have a more direct path to efficient frontier. But we're following what ChatGPT says, right? And there's value in learning that. We can always loop back and start looking at other options, okay? So, not trying to shoot down your idea, but let's put a pin in that idea for now. Yassine, hello, sir. Yassine, our friend from Tangier, Morocco. Glad you're here, Yassine. Good to see you. What is the argument for the period choice? Yassine's none so far. None so far. I mean, one, it could be a requirement of the efficient frontier, right? It needs daily results. Or two, it becomes a hyperparameter for us, right? That becomes something that we test. Well, we looked at daily data. What happens if we look at hourly data, at data for each 4 hours, every other day's data, right? So, Yassine, this is why we do these explorations, right? Because we really don't know yet. So right now, Yassine, the answer is none. It's just what ChatGPT picked. Good question, though. Manoj says, agree with AJ, but I have no idea about the package portfolio. Okay, well, we're about to find out, right? And guys, again, this is why we do this. We haven't said that Efficient Frontier is going to be our final deliverable to the client, right? This is me, the chief data scientist, telling you guys, hey, let's take 2 to 3 days to figure out if that's possible or not. Great idea. I just want to make sure that there's a path to a viable model there. That's what this is, right? There's been no final decisions made. We're still exploring, right? We're still kind of setting ourselves up to say, hey, we think that these are the 3 good ideas, but this one idea is our most direct path to success. That's really all we're doing here, right? But appreciate all the feedback. This is good, guys. So with the code on the screen, I think it looks fine, right? Very reasonable code that should run, saves everything to a CSV file in a very similar format how we have here. We have our news files, we have our MST, which is just our price files. So this is the only difference here, is that this one's going to give us the historical data. But otherwise, I think this is very reasonable code. Let's go ahead and run this. EFF collection.py is what we're looking for. So let me look for that. Yep, there it is. So Python. Okay, so it looks like it saved all 3. So we'll still focus on Microsoft. So this is our new CSV file, and there it is. So it's going to give us the date, the open, high, low, close, volume, dividends, and stock splits. Seems reasonable. So this is me, the chief data scientist, not knowing about Efficient Frontier. Some people in the chat have already said that they don't know about it either. Okay, so we have Manoj and AJ, who seem to be a little bit more advanced. All right, guys, what do you think? Does that sound like the inputs that we need? Does that sound like enough inputs for your proposed approach? What do you guys think? Let me know in the chat. Maybe we need more inputs, or maybe this is enough. I honestly don't know, but this is where you rely on the subject matter experts, right? What do you guys think? Is that enough? Are we on the right track here? I just realized that I also want to add GLD to this, because gold is another one that we've been working with quite a bit. Let me quickly rerun that just so we can get the gold data too. Okay. What do you guys think? Is this are these enough inputs? Freddie says, I think we need more theory to answer. Yeah, maybe. And Freddie, welcome. I think it's your first time. Thanks so much for joining us on YouTube. Really glad to see new people, so thank you. More theory to answer. Maybe. Maybe. Osama says we need more inputs. Okay. Osama, what are you basing that on? Do you know the efficient frontier? Or is that just more of a gut feeling? There's no wrong answer there. I just want to hear your rationale. What is your rationale for needing more inputs, please? And Manoj said, but because Manoj is kind of disagreeing with you, right? Manoj is saying that's enough. AJ says the argument period equals 1 year, caps our data only the previous year, omitting the argument will fetch the entire stock price history. Yeah, we can do that, AJ. But again, AJ, that could be a hyperparameter, right? But that comes in the testing phase, in the experimentation phase, right? But yeah, we can certainly go with more data, but right now we're just scoping things out, right? I mean, look, at this point, we don't even know what library we're using, right? So we don't want to get too married to the individual parameters at this point. We're just kind of, you know, we're just testing the waters. We're just kind of seeing where we're going, okay? But so Manoj seems to think that these columns are enough. And it's what ChatGPT gave us, so presumably ChatGPT thinks it's the same, right? Manoj says, agree with AJ. Yeah, I hear you, Manoj, but I'm, you know, same answer, right? We're just scoping things out, guys, right? No final decisions are being made. We're just seeing if there's a viable path to an answer. All right? All right, so let's go back to our ChatGPT and ask. So, you know, it gave us data, but how does this lead to the efficient frontier calculations that we need, right? So let's go back. Okay, so this looks interesting. This looks very interesting. All right, so here's the 4 items that ChatGPT tells us we need for the efficient frontier. We need to calculate the daily returns, compute the expected returns and the covariance matrix for each stock, and then use these to simulate returns and volatilities, varying the weights of each asset, and identify the optimal portfolios along the efficient frontier. Okay. So my biggest takeaway from that is that we have enough data, right? Because the first two are your biggest data needs, right? The daily returns and the expected returns and a covariance matrix. You can get that just by the opening and the closing price, right? You don't even need the highs and lows. You just need the opening and the close, right? Did you make money on a given day? And then everything else will just be a computation that the code itself does, right? It's going to bring in all your files. It's going to put them in a CSV with the stock ticker as a key. And then it's just going to keep going and going, right? Yeah. And you can see here, it actually only uses the closing price. So this looks pretty normal to me. And then down here is where the simulation starts, right? Because if you guys remember, if you attended before, Efficient Frontier is a Monte Carlo type of approach where you're basically trying different combinations of portfolios. So that's what we're seeing here. It's going to run 10,000 simulations and basically just try all the different permutations and give you the returns, the volatilities, and the Sharpe ratio. And then it's going to tell you the max Sharpe ratio portfolio and with the minimum amount of volatility. So those two sound like very reasonable measures to use. And then on top of that, it's going to give us some plotting also. So I think this code looks fairly reasonable. There's a couple of changes I want to make because, well, let me bring it over into Visual Studio Code first. I'm seeing some good questions in the chat. I will get to them in just a second. So this one we'll just call EFF. And here's the code. So I'm liking this code. It should show us a pretty good number of results. The only part I want to change here is that I don't want to get all CSV files because we have other CSV files, but I'm okay getting all of the ones with historical data in the name because those are the ones that we know were created for this EFF, right? So Astra historical data CSV. Yeah. And I want to go ahead and print data. Oh wait, no. Print. Yeah, print all files. I want to see what are the files that it picked up just in case. Okay. All right. So Osama says, in my view, more microeconomic information is required. Remember that Osama did mention that he was not comfortable with the inputs, right? He was with this being the only inputs. AJ says, I have no knowledge about efficient frontier analysis. Could we ask ChatGPT something like explain efficient frontier analysis like I'm 5 years old? Yeah, great suggestion. We'll do that, AJ. Let me address Osama's comment first because I think it's an important comment. So Osama, it's a tricky answer because the question isn't, do we have enough inputs for modeling? The question is, do we have enough inputs for efficient frontier modeling, right? If we were still at a complete stage 0 where we didn't have ideas, then yeah, we would definitely benefit from more microeconomic data, right? Or any type of data at that point, right? You could even look at macro factors like, unemployment rates or something like that. But we've narrowed down the entire field of models to these 3, right? The sentiment analysis, the news sentiment analysis, the time series, and the efficient frontier. And more specifically today, right now, we are focused on the efficient frontier. So I hope that helps you, because you have to stay focused on the problem in front of you, not all of the possibilities, right? Like, I appreciate that you're still trying to have like this ideation phase and still kind of keep an open view. Like, I love that. That's super valuable. But at this moment in time, we are kind of trying to narrow it down, because we can't get stuck in looking at every single possible model, right? We have to make decisions at some point, right? Like I said, I have to make decisions just to keep the series moving. But in a business environment, in an actual data science team setting, at some point you have to say, hey, this is the approach we've chosen, and we're going to make the most of this one approach, right? So I hope that helps, Osama, because, you know, to me, this looked like enough data for efficient frontier from what I know of it. And we kind of have to kind of control ourselves and say, okay, well, wait a minute, you know, we're no longer at that open view stage where we can still say, oh, bring in this, bring in this, bring in this. We have to make decisions at some point, right? The project has to keep moving forward. So I hope that helps, Osama. So AJ says, could we ask ChatGPT, like, explain efficient frontier analysis like I'm 5 years old? Okay, sure. I think the code helps us understand it a little, but yeah, sure. Clearly, you're not the only one in the chat that doesn't understand it, right? So I think this is valuable for us to do that. Okay. All right, so I'm going to leave that up on the screen so you guys can read it. Okay. All right. Let me know what you guys think, if that helps. But I think the bigger takeaway for all of us here is this. When everything else we've looked at, the new sentiment, the time series, is focused on one stock, right? We were just looking at Google. We were just looking at Microsoft, right? When we were looking at the articles for Microsoft, we only looked at Microsoft topics. Efficient Frontier is saying, well, look, you don't buy one stock, you buy a portfolio of stocks, of investments. So this is trying to help us find the best mixture of investments, not just the best stocks alone. So I like this because it helps us kind of take another view into our entire project, right? So it helps us think about it as a portfolio, and that's valuable. It's valuable because now we are taking a fundamentally different view of the project we can create for our client. Because now we can say, well, if we choose path A lets us do per stock, per single investment. Whereas this one, the Efficient Frontier, is the entire selection of investments, the entire portfolio. So to me, this is one of those like dividing points where you approach the client and say, here's option A, here's what that looks like. Here's option B, here's what that looks like. What would you like for us to do? That's a very valuable approach for your clients. So Manoj says, yes, Efficient Frontier technique can handle multiple stock investments. Yeah, clearly, right? Okay, so AJ, Lakshmi, does this help you guys? Because, you guys have expressed, some a knowledge gap with Efficient Frontier, and that's okay. I'm glad that you guys stepped up like that. But what do you guys think? Because to me, the way they explain it makes sense. And you can see that in the code. Let's go back to the code. But AJ Lakshmi, let me know in the comments. But if we go back to the code, we can kind of see that, right? Here, it's going to go ahead and collect all of the historical data files we have. In this case, we only have 4, but we'll do more. And it lets us know that it's going to use the close price, right? It's going to get the daily returns. It's going to get the covariance matrix. In other words, how crazy does the stock move, right? Like the volatility of the stock. And then it's going to do a simulation. And it's going to say, here, returns are good. You want more returns. And volatility is bad. You don't want so much volatility, right? You want returns that are straight up, right? You don't want returns that are jumpy up and down, but still end up straight up, right? There's a difference. So that's what this is telling you, where it's going to show you the ideal portfolio that gives you the lowest volatility with the highest returns. Right? AJ says, I don't understand how we calculate the returns. By looking at the, it's up here, right? By looking at the close price. That's why price is included in this data, right, AJ? Because we're looking at the closing price to tell us how that stock did. So that's where that's coming from, okay, AJ? But look, I think we're on the right track here. I love the fact that, like I said, we have like kind of like these two paths to the same end, right? Because again, our client doesn't really care how we get there. They just want the best returns possible, and we're going to give them that by being able to give them those that gain of the width, right? Of being able to look at so many different combinations. Because you guys realize how many like combinations there are of even just like 25 different possible stock symbols? I mean, what is that? That's basically a 25 factorial, right? Like that's a lot of combinations. Like the man hours it would take to figure those out is like impossible, right? But we're going to be doing that here. And that's where part of that win is. But more importantly, and I mentioned this in our first session because I know I get approached a lot about going into quant finance. I get a lot of questions from people who say they want to be quants and all that, right? What I mentioned to you still holds, that in quant finance, you have to have an investment thesis, right? Every single quant finance presentation I've ever sat down through always starts off with, what is the investment thesis? So we have to develop that investment thesis, right? So we kind of have two theses going on right now. Well, 3 technically, right? But if we think about what we did last week with the time series and more of like that single stock type of approach, we can say by examining single equities, we can use machine learning to help us do time forecasting 3 days into the future, 5 days into the future, whatever the case may be. The second investment thesis is by using the efficient frontier theorems, we can create an entire basket of goods that are going to give you the maximum result with the minimum volatility. So we can present you with individual stocks, or we can present you with with customized portfolios, right? So I want us to think about it in those terms, because having those investment thesis, those things that are basically driving your experimentation, is essentially how professional data science is done, right? This isn't just us like, oh, I really like Tesla and I really want to invest in Tesla. No, you're starting off with the thesis, and then you're letting that thesis drive your discoveries. That makes sense? Because it's kind of a little bit of a shift that you have to make, but But trust me when I tell you that this is like how data science is done in that professional way, in that professional environment. What is the investment thesis that you're basing all of your work on? Okay. All right, so I think we're ready to run this. I think we're ready to run EFF.py. We have 4 different stocks that we put into our collection, right? We have Apple, Gold, Google, and Microsoft. We're going to have to expand. My gut tells me we're going to have to expand that list for Efficient Frontier. But that also is going to expand the processing time, right? So we kind of got to work on that. But let's see where we head down this road. So I think we're ready to run this. Let me look at this again. EFF.py, yep. So let's let this fly. Oh, I'm new here. All right. So it's using, yep, it's going to go ahead and use our 4 files, right? Historical data, which is great. And it's going to tell us our portfolio with the maximum Sharpe ratio, a 31% return and a volatility of 0.12. Okay. And then our portfolio with the minimum volatility is 0.28 returns and a volatility of 0.120. So not much difference in the volatility there, right? And then it also gave us this chart. That's a pretty looking chart. Okay, so the colors are the Sharpe ratio. The x-axis is volatility and the y-axis is return. So what do you guys think? I can see why this is chosen because this is the highest return possible, period, right? There's not too many that go higher than that. And this one is your highest return at the minimus of the volatility. So I understand why those are the chosen portfolios. So I kind of get it. I understand why these values are chosen. And it's a really nice visualization too, right? But what do you guys think? I'm going to put this to the side here so you can see the numbers too. By the way, a 31% return in the US stock market is excellent, right? That's you're doing all right. 28% return, also pretty good, right? Now, coming back to AJ's comments and maybe Manoj's comments also, this is just for the last year, right? Overall, US stock market has been great the last year. So you could have made some of these numbers just by guessing randomly. But, you know, maybe this will change when we go 2 years, 3 years, 4 years, 5 years. 5 years, now you're including COVID, right? COVID was a terrible time for the stock market. At least the initial parts of COVID were, right? So to AJ's point and Manoj's point, we're going to have to experiment with different data horizons. We're going to get completely different answers if we do different data horizons. Or as we add more stocks, right? We only have 4 right now. We should be doing this with like 4,000 stocks, right? So what do you guys think? Again, not making final decisions, but this is an exploration. Does it feel like we're on a viable path here to you? Like, does it feel like, hey, we might get something out of this? That's all we're trying to answer. So let me know. Let me know in the comments. What do you guys think? Matari, welcome. So glad to see you. Matari, I think you just joined in the last week and now you're like a daily watcher. Love seeing that. Join late, trying to catch up on the topic. Okay, well you're a smart person. You'll catch up just fine. But Matari, right now the question in front of the chat is, what do you think of the graph? What do you think of these results so far? These are the results that it's showing us with the maximum returns and the minimum volatility. So this is looking pretty good to me, but what do you guys think? What do you guys think of our work so far? AJ says, does this give the optimal portfolio percentages for each selected stock? That's right, AJ. That's the point. Now, we need to modify the code to show it to us because to your point, it has an output, the actual equity name and proportion yet. But we'll go back to ChatGPT for that, right? But again, let's just go ahead and look at the viability. Does this smell right to you guys? Like, does this look like we're on a viable path? Right? But I agree with you, AJ. We need to optimize it just a little bit. Just a little bit. But anybody else have any thoughts, any comments? What do you guys think? Some of you weren't comfortable with Efficient Frontier, but now maybe this visualization helps you understand it a little bit. Now with the code, you can see how it's a simulation approach. And by the way, guys, that also becomes a hyperparameter, right? We did 10,000 simulations. Some people would say that's good. Some people would say that's not enough, right? The more simulations you do, the more you converge on an answer. Is 10,000 that number? We don't know, right? We could be this far apart, or we could be this far apart, right? We'd have to run a lot more simulations, see where those numbers are converging, right? Yassine says, I think it's good. Okay, cool. Freddie says the Efficient Frontier is between those points. Freddie, I don't think so. Good question, by the way. I don't think so. I think the Efficient Frontier is basically anything along this border here, right? And then you're choosing basically like the level of volatility or that you're comfortable with, right? Because really, if you look at if you take away the two starred points, anything along this frontier is going to make you money, and it's going to be relatively low volatility, right? And things out here will still make you money, but it's a lot higher volatility. So I think the frontier is referring specifically to this edge, and then you just choose, kind of what you'd like or what you're comfortable with for your own investments, right? Like your own tolerances. And in some cases, by the way, there might be requirements of how much volatility you can or cannot accept in portfolios, right? Depending on whose money you're handling and things along those lines, right? You could have more appetite for volatility or less. It just depends. So I think the frontier is really anywhere along this line here, Freddie. So I hope that answers your question. AJ says, sorry, still a little confused on the buy-sell points of the stock. Okay. Give me just a second, AJ. I want to come back to that. Yassine says, can we select some combinations that are considered good and do more experimenting on them? What kind of experimentation, Yassine? I'm not sure if there is any more experimentation. Let me know. AJ says, is the returns calculated based on the closing price on the start date and end date only? No, it's every day, AJ. Every day, because you have to do it every day to get that volatility. If you only did it on the start and end date, there'd be no measure of volatility, just gains, right? You can measure gains that way, but you can't measure the volatility, right? So no, it's every single day, AJ. Every single day. Denelson says, I'm taking this all in. Love these sessions. I agree with this being a good set. We should add more years just for the sake of curiosity. Yeah, Denelson, I agree. Expanding our historical data is absolutely a good next step. Absolutely. Fabry says, what are the weights of the asset allocation? Yeah, Fabry, welcome. So we don't know that yet. And that's something we do need to ask ChatGPT to refine, because it doesn't show that to us, right? And we definitely want to know that. So yeah, to your point, Fabry, we need to adjust the code. And I think Manoj made the same, somebody else made the same point, right? That we do need to do that. We do need to ask ChatGPT to show us each one of these portfolios, right? It told us what the returns would be, but not the portfolios. Manoj says we need more data. Well, we don't need more data on the input, only on the output, Manoj, right? We want to be clear on that. So Manoj, I want us to be clear on that because we did have some discussion earlier where people were saying we needed more data. We need more data on the output side, not the input side. Okay, so let's just be clear there. Because clearly we have enough inputs, right? Okay, so let me go back to AJ's question. AJ says, sorry, still a little confused on the buy-sell points for the stocks. Yeah, great question, AJ. So here's the thing, guys. We're not there yet. A single instance of efficient frontier is not going to tell us that, right? AJ's question is looking forward ahead to the implementation side of this model, right? Because look, again, we're just exploring, guys. We're just feeling things out. We're just seeing if there's a viable path. That's all we're doing today. But this approach gives us a moment in time, right? You gave me, here's all the prices. Here's all the possible investments you're looking at. This is your ideal mix right now. That's what this is telling us. But guess what? Tomorrow, there's a whole other data point, a whole different set of closing prices, right? So tomorrow, we'll rerun the model, look at the ideal mix then, right? Based on the simulations. And then we'll have to adjust our portfolio and says, oh, wait a minute, this is today's portfolio, but today's run from today's closing data tells us that we should be adding in some IBM. Okay, so now we're buying IBM, right? And then that becomes your portfolio. Oh, wait a minute, this time it dropped gold. Okay, so that means we need to sell gold because gold is no longer part of our optimal mix, right? Another way to do it, a second way, AJ, is to also say, okay, well, look, this is the portfolio we started at the beginning of the year. This is what the efficient frontier told us. So now on any subsequent runs, I'm just going to use the stocks that were in that portfolio. And I'm going to let it say what is my optimal return. And my return here, as you can see here, the optimal return that we got was 31.5%. Well, what if on a daily basis that only changes to 31.4, 31.6, 31.2? Maybe you're dealing with a portfolio manager that doesn't care about that and says, look, I may not have an optimal portfolio, but I still have a pretty good portfolio, right? That's a valid approach to use this algorithm too. That I'm not going to try every single investment. I'm just going to try my investments, my portfolio. And I'm going to give myself a tolerance to say, as long as I'm getting above 30%, that's all I care about. It could be 30, it could be 30.5, or it could be 37.5. I don't care. Just keep me above 30. And that could be the way that you use to price and sell, right? Because this is about the mix. It's not about saying, do this, do that, do this, do that. Like, it's not going to be like a self-trading program. That's not really the goal here. But my point is that there's different ways to implement it. Some of that will be our decisions. Some of that will be client decisions. You know, we'll kind of have to make those decisions in conjunction with the client. But that's implementation talk. And it's okay for us to look ahead of that. But Just keep in mind that there's multiple possibilities there. Okay? Yassine says, I don't fully understand the method. From what I understood here, the returns are calculated using some method. Maybe we can use a different one, or maybe I'm having it all wrong. So Yassine, I think that Yassine is not the only one feeling this way, right? And my goal here is not to teach you guys quantitative finance. My goal here is to teach a data science project. So let's make sure that, first of all, we take a step back and we appreciate the process that we're going through, not necessarily the individual calculations. And I say that because, not everybody's interested in finance. Not everybody wants to be in quant finance. But really, the value of the lesson is in being able to see the exploration, the discussions, the differing points of view that we're having. That's really what I'm trying to teach you guys, right? So Yassine, for the purposes of your question, really the only thing I want you to understand is that we have a couple of competing approaches that to solve the same client problem. Okay? So I want you to think of it as different branches that we can have. In our first branch, we can be looking at individual investments. So last week, when we were looking at charts and descriptive analytics, all that, we were just looking at individual stocks, individual companies, just Google, just Microsoft, right? In this approach, we're looking at multiple investments as one, as a portfolio, right? In this approach, we're saying don't evaluate individual stocks, evaluate the entire portfolio. That's what we're saying here, right? I don't care about the individual stocks. I just want to care about the portfolio, right? So that's what we're trying to do there, right? So just keep that in mind, Yassine. And we're doing that because they make for two very good, but also very different, very distinct investment thesis. And that's, you kind of want that, right? You want to be able to approach your client with multiple distinct ideas, okay? Yassine says, I'm very sorry I got out of the scope. I'm just confused. I got here. Don't apologize. These are long tutorials, so I understand that people will come and go, and that's okay, right? But really, I'm more concerned that I'm teaching you guys too much on the quant side or on the finance side than what I wanted to, because I'm not trying to teach a finance project. I'm trying to teach any project, a framework for any project. Okay? All right. So I think we've agreed as a group, more data and to see the actual assets that are going to be allocated, right? And then more potential investments, right? Because right now we only have four stock symbols. That's nowhere near simulating what we would do in real life. So let's go fix those three things and we'll see where we end up. We'll see how different this chart looks, right? Because this chart has the potential to completely change, right? So let's see. So we really just needed to change that output, right? We just need to have more information on how it's getting those returns, right? So this should be a fairly simple change. Okay, so it's still loading the data, getting all the file names, getting the close price. getting the covariance matrix, 10,000 simulations. Oh, we also talked about doing more simulations, right? So that's also an important, it's going to do all of that. And then, okay, and here it is. It's going to tell us the return, volatility, portfolio ID, and then identify the portfolio. And then, okay, here is where it is for stock weight and data keys, max short portfolio. Okay. Okay. That looks pretty normal. So let's go ahead and replace our code, right? Is that, and we need to just change it up here. Okay. I think this should be basically the same approach. So let's see what this gives us. Okay. All right, guys. So maybe this will help illustrate it a little bit more. So you can see here that it's the same results, right? No surprise there. With simulations, you should get some variance, but we don't have enough stock symbols to really cause a lot of variance. So again, 31.7 is our return, but this time it's going to show you 11% Apple, 70% Gold, 16% Google, and 2% Microsoft. So those are the proportions that this approach requires. Or you could adjust it slightly. I guess here what the difference is less Gold and more Microsoft, right? And virtually no Google. Wow, that's basically like almost zero Google. And then this is what your portfolio should look like. Right? So I think that looks pretty reasonable. And our chart looks the same, which again, it should because we don't have a lot of different stocks, right? So I think that was a good change, right? Let's add some more stocks. Because what I really want to get to, guys, is I want to start showing how your best return is not always your least volatile portfolio. So let's start adding some more ticker symbols. Okay. So, and as we add more ticker symbols, we probably also want to add more simulations, right? Because more ticker symbols, more permutations, more simulation you should be doing, right? So we actually need to go back to our collection and start collecting more data, right? So if you guys want something, put it in the chat, but I'm just going to include some common symbols. IBM. Who else do we want to include in here? NVIDIA. NVIDIA probably caused some outliers over the last year. Anybody else? Who else should we include in here? Well, we can. Do we want to include the S&P? No, we probably don't want to include that. So Fabry asks, that's the amount you should invest in each stock to get the highest return and lowest standard deviation. Yeah, Fabry, that's a way of thinking about it. Sure. Palantir, that's a good one. I like it, AJ. I like it. Anybody else? Oh, you know what? One of my favorites. I was fortunate. It made me some money this year. Is Starbucks. I think is there a U in Starbucks? I think there is. Yeah, but Starbucks has been very, very good to me. We can include some of the ETFs. So there's the oil ETF. What else is there? There is what else can we include? Feel free to throw in some stock symbols. What else do we want to include in here? We can include Ford as the car makers. We can include Let's include a homemaker, DHI. They're a construction builder. So yeah, well, that's a good mix, right? APP. Okay. Any other suggestions? Last call for suggestions. Oh, come on, Dennis. Okay. So we have more symbols. Oh, and we also want to go more data, right? Is what we said? What do you guys think? Let's double our data, 2 years. All right. Bitcoin is not a stock though, right? I mean, I know that there's ETFs for Bitcoin, but it's not a stock per se. So we're going to leave that out for now. Michael says, happy Sunday, Sir Dennis and everyone. Very busy 2 weeks. Haven't had much time to join the classes and chat. We'll watch later. Thanks so much. Oh, Michael, thanks so much. Appreciate you being here. Michael, you are from Nigeria, right? Yeah, but you've been here a couple times this week, if I remember right. So glad to see you, my friend. Hope you're well. All right, so let's run this. And we're going to go 2 years. And so we're going to adjust this, and then we're also going to adjust the simulations. In reality, we would do a lot more than this, but just you know, let's just double it, right? We don't want to get too crazy. You know, we can ratchet up, but let's just double it for now to 20,000 portfolios. Fabry says, include more healthcare. Yeah, that's a good idea. I'm trying to remember what the healthcare ETF is. I want to say it's XHV is the name. But if you guys want to look it up and look up what some of the healthcare ETFs are, that's a good one too. But I think I have enough here to make my point. But let's see where we end up. So we got to run our collection first, and then we're going to run our other stuff. So EFF collection. So quite a few more stocks there, right? And now we're going to run our EFF again and see where we end up. Okay. All right, guys. Look at this chart. Give me your observations. What do you think about this chart? And what do you think about these mixes? If you see here, this is what I really wanted to illustrate. Look at this. In your highest performing portfolio, you don't have any F stock. F is Ford Motors, by the way. I like Fords, you know, I had a Ford Mustang for a long time. I love Mustangs. So, but Ford stock, you should have 0. But if you're willing to get more returns and accept a little bit more volatility, or less volatility rather, less returns, less volatility, you got to put some Ford back in there, right? So that's an interesting conclusion. You've gone from 0% to 10% in Ford. Everything else, a couple of the same. Or look at this, you go from 3% Apple to 13% Apple to lower your volatility. And let's look at this chart. This chart now looks completely different. I think it was Freddie, right? Freddie was asking, for Freddie, look at what your frontier looks like now. This is your frontier, right? The outer edge is always going to be your frontier. So this is saying that at this point is basically like the peak of it, right? The apex of it. Because anything lower than this, you're hurting your returns. Anything higher than this, you have to accept more volatility. Right? And then also another thing to consider, guys, look at the scale of these returns. 0.6 returns. That's like double what we saw earlier. That's amazing, right? So we changed more simulations, more data, or a larger time frame in data, and more potential portfolio components, right? Completely different chart, completely different answers. So we're getting a little bit of a taste here for the experimentation, right? What do you guys think? Give me some feedback here. What do you guys think? Two completely different portfolios. Look at Nvidia. Nvidia, if you want high returns, you should be holding 15% of that. But that may be too much volatility for you, for your taste, for the client requirements. If you want low volatility, guess what? Your Nvidia should only be 3%, right? Let me bring that chart back up. Sorry. So what do you guys think about that? The closest price data you use also is after dividends. Yes, I believe so, because Ford pays in dividends more than in price. Yes, Fabry, you're right about that. But again, we're not trying to get too caught up in the finance side. We're trying to get caught up in the data science side, right? We're not a team of financial experts. We're a team of data science experts. So the type of feedback you're giving is what I would expect the client would give us. But we shouldn't be making those decisions, those statements. That's not our function in this relationship, right? So I hear you on that, but let's stay focused on the data science side, because that's ultimately what the best competency of our team, right? What do you guys think of this? I think this is very interesting in terms of the differences that we got just by looking at more data and more potential members of the portfolio. And then if we think about using this as a baseline, right? We know that, you know, our stock selection here is kind of is shaded to the technology side, right? What happens if we add healthcare? What happens if we add consumer goods? That in a way almost becomes a form of experimentation also, right? Or we can come up with different indexes. We can come up with different portfolios to propose to the client. Here's what our data science algorithms say if you go heavy on tech. Here's what our algorithms say if you go heavy on car makers. Here's what it says if you go heavy on consumer goods, right? Clothing, groceries, stuff like that. AJ says, did we add more data? Yeah, we went back 2 years, AJ. We went back 2 years and we added more possible investments, more available investments. So we went deeper and wider in what we let the simulation look at. Okay? So I think this is interesting in that regard, right? That there's different ways you can cut up the data in the way that you're going to deliver this to your clients, right? Like there's many possibilities here. You know, we talked about those branches of the investment thesis. Well, the investment thesis can be composed of different other sub branches, right? We think that we have a simulation to help you with portfolios. From that simulation, we think you should be heavy on tech and on car makers. Here's why. Because we tested them against other baskets of goods, other portfolios, and these did better, right? That's a valid way to approach your foundational arguments for why you're choosing these recommendations for your clients. All right. So let me go ahead and keep on telling me if you have any other questions, right? But I want to go back to the code. Actually, I think I got to close this. Gotta close that out. All right. I want to go back to the code because I want to talk about one more thing, guys. So this is going to be, as I said, my entire goal here is to be teaching data science, not necessarily quant finance. But there's a very important lesson between last week and this week. Let's take a quick look at last week's code, actually. Here's the code we worked on last week, right? And we know that profit only requires two different inputs, right? The date and the price. That's all it cares about. And then, profit's claim is that that's enough information for it to make time series forecasts, right? And you can see here that we are collecting the data. Here's the two items, the two columns. And then here we initiate profit. Here is the model fit, right? This is where profit takes our data and fits it to a model. And then from here, it's actually using the model to make the future predictions. And then from there, it goes into a plotting function and it shows us the upper and lower bounds and whatnot, right? So here's, basically everything before this is all data. Here's our model fit to create the model. And then we can go ahead and do a forecast because we're using that model. And if we love that forecast, we can save the model, right? We can say, great, save that model so that in future instances, I only have to show you the most current data and you can give me a forecast on that, right? And that becomes your final product. That becomes what you actually worked on, right? Let me run this code again, just to kind of remind ourselves, right, of what we did. So give me just a second here. Here's profit for alpha. So if you guys attended last week, we were looking at a chart like this. This is what this produces, right? This is telling us I took the information, I created a model, and here's what the model looks like in real life. The light blue, the band, is the upper and lower of my predictions of the inferences, right? We talked about like the y hat inferences, y hat upper, y hat lower. The blue is the y hat inference, right? What the model thinks is going to happen. And then this other blue line is what tells you, the lighter blue line is what actually happened, like the ground truth. So obviously you would like to stay within those bands as much as you can, but typically speaking, this is what we get out of profits meta, right? So here's what I'm really trying to teach right now. Go back to the code. We go back to the code. This is profit. Collect the data, fit the model, use the model. Right? Fairly straightforward. Here's the efficient frontier code. We get the data, we run the Monte Carlo, and then we show the results. What's the difference? There's a difference there. If you think about how I just explained it, what is the difference in my two explanations? And if you want help in thinking about it, think about this question also. What is an algorithm? What is an algorithm? We know that data science produces algorithms, but what is an algorithm? Think about that and give me your answers in the chat. There's no wrong answers. This is just a discussion. But this is kind of like the meta point that I'm really trying to teach today, right? Like I had this goal in mind. I didn't know exactly how I was gonna get here, but this was my goal of what I wanted to teach you guys today, because we're at an important point for it. But let me know in the comments. What do you guys think? What is the difference in what I just described between how we did things last week with Profit and Meta? Rex says an algorithm is a series of instructions. Okay, Rex. I like where you're going with that. Give me more. You're on the right track. Keep pulling on that string. Or anybody else. What is an algorithm? What is an algorithm? You know, simple question, right? What's an algorithm? Rex is definitely on the right track. So if you want to build on Rex's answers, you'd probably be on the right track too. But yeah, well, what is an algorithm, guys? Or what is the difference in the way I explain things to you guys? Denelson says they are operations or steps that are followed to receive an output. Okay, cool. So tell me about that, Denelson. Think about the steps I just told you, right? In Profit, data, fit the model, use the model. In Efficient Frontier, get the data, run the simulations, show the results. Yassine says, in Monte Carlo, there's no weights that can be adjusted in the future. Okay. You're on the right track. But give me the okay. Yassine got it. Okay. The Starry Vibe says it defines a process to go from a given input to an expected output. Yeah, okay, keep going down that road, Starry Vibes. What else is there? Keep going down that road. Give me the next layer of that answer. Yassine is definitely approaching the right answer. In Monte Carlo, there's no learning. Okay. Fabry says initialize variables, build the logic, get outputs. Yeah. You know, Starry Vibes, Fabry, Denelson, and Rex. You guys are all basically giving the same answer, right? You know, in different ways. But let's focus on what Yassine said, because Yassine is 100% on the right track. In Monte Carlo, there's no learning. Because wasn't that one of the differences I just told you guys? In Profit, I told you that we fit a model. We take the data, we send it to a fitting process, and we fit the model. If you remember, if you were here for the neural network stuff we did, right? We did PyTorch versus Keras. We also fit models there. We also saw that when we did the Julia showdown, right? The Julia and Python showdown. Because we use the neural network for that, right? But guess what? In Efficient Frontier, we didn't fit a model. Where's the model fit? There's no model fit. There's nothing there to fit to, right? So Yassine's right. In Monte Carlo, there's no learning. Now, the only thing I would change in there is I would take out the Monte Carlo portion, because this is not exclusive to Monte Carlos, right? So two things that here's the big takeaway, right? Two things. One, what is an algorithm? An algorithm is a formula. It's usually a math formula. But you know, you guys were talking about it being a set of steps, right? And yeah, that's accurate. It's a set of steps. That's it. It's a set of steps, processes, manipulation, whatever you want to call it. formulas or mathematical operations that you do. That's it. That's all an algorithm is. And I'm putting an emphasis on this because people always think, oh, well, algorithms means neural networks, or it means that I'm using some fancy library. No, it just means you're doing a math operation. So both of these are algorithms, right? Even though there's no fit model in this Monte Carlo approach, there's clearly a process that we're following here, right? This is still an algorithm. So I want you guys to remember that, okay? Because people tend to get too fancy with the algorithms, right? The difference, though, is that there's nothing saved. This is the second part I'm trying to get to you guys. There's nothing saved for the model. There's nothing to save, right? If it's a math formula, you can't really save a math formula. You can save the outputs, the portfolio outputs, the recommended weights of the portfolio, but that's not really a saved approach to use in the future. Like the meta, like the profit by meta is, right? Because the profit by meta, we haven't shown it yet, but you can save that, as a pickle file or something else. You can save that for future predictions, and that's really what becomes your deliverable, right? But not every approach out there requires you to save something. It's literally just an order of steps, an order of operations. That is also a valid algorithm. So that's really kind of what I'm trying to, have you guys understand. And more specifically, there's a name for this. You have your fit models that you can save, right? A pickle file, or sometimes they have their own methods for saving or whatnot, right? Or you're saving a weights file, as I think Yassine mentioned, right? But then on the other hand, you have these that are essentially just scripts, just formulas. And these can be, they have different names, but I learned them as lazy loaders. And they're called lazy loaders because when you hear that, you should be hearing something it's at runtime, right? Because that's basically what this is. This is a runtime algorithm. There's nothing to save. There's no other model. There's no pickle file. There's nothing. You just run the script when you want to. But it's also doing it kind of like at that same time, right? That's why it's called a lazy loader, because it just loads things as it needs it. If you were to Google that, or you were to research further, you're going to find other instances. So Monte Carlos tend to be lazy loaders. Bayesian approaches, right? Like, Bayesian algorithms are also lazy loaders. You typically don't save a Bayesian algorithm or model, right? I mean, Bayesian is mostly like formula based, right? So those are typically lazy loaders. And that's really kind of like the meta topic I was looking forward to passing on to you guys today. Because realize there isn't always a fancy library. There isn't always a way to save it. There isn't always a clear way to organize your models and say, this is my training, this is my prediction, this is my runtime. That's not always the case. Because with those lazy loaders, it's just a collection of files. Now, you might take those files and create an API from them, or load them into a bigger package or whatever. But the lazy loaders are still valuable. They're still very efficient. They're still good algorithms, good formulas in there, good order operations in there. But just because you don't save them or anything doesn't make them anything less powerful. Right? But what it does do is sometimes it makes it slower, right? Lazy loaders are typically not known as fast algorithms either. Now, yes, there's ways that you can optimize your code and stuff like that. You can find performance gains, but they're called lazy loaders for a reason, right? Because they don't really learn anything. They process things. There's nothing to save, but they do process your data. So really key point. It took me a while. When I was a student, it took me a while to realize that. Like, what do you mean that's not in a library that I can save? Like no, and an algorithm isn't always fancy. An algorithm is just a math formula, right? Just an order of operations. So keep that in mind, guys, because that's really the meta lesson that I wanted to get across today. Because again, I'm not here to teach quant finance. I'm here to teach you data science. And that's a very important distinction in data science. You're going to have your fit models, your saved models that have that training and runtime distinction. And then you're going to have your lazy loaders. And that's okay. That doesn't make them any less valuable. It's just the way it is, in the world of data science. Okay? So I'll stop there. I hope that makes sense. Super valuable lesson for you to carry forward. Coming back to our investment thesis, right? Remember I told you had two branches, right? We had our single stock forecasting, and then we have our portfolio combination, ideal portfolio weights, right? But guess what? We have another differentiator. And by the way, Mr. Client, if you want to do fast operations, you're going to be doing like a lot of trading. We recommend this approach because this is a saved model that runs really fast. But you also might be somebody who only wants to trade once a week, or you only want to rebalance your portfolio when you fall out of certain parameters. Okay, we can do that. We can do that with our lazy loader approach. Not as fast, but fast enough for what you need. Right? So now you're creating solutions that fit your client's desires based on, we can do it really fast or we can do it lazy loader, right? So I hope that makes sense to you guys. I'm really glad we got there because, like I said, this is kind of like the big thing I wanted to leave you guys with, because super important, super important. Lakshmi says lazy loading is alerting other. I think I use lazy loader enough, right? I said that enough. But yeah, guys, I mean, I just love that we've now come up. We ideated, we innovated 3 different possible solutions, and we also scoped them out, right? We scoped out the sentiment analysis, we scoped out the time series, and then we scoped out the efficient frontier. So, all right. So help me out here, guys. Let's go back to the new sentiment analysis, right? That's the one where we said by looking at the sentiment in news articles, we can figure out if the stock is going to do well or not, right? All right, guys. So here's the question. Let me know in the chat. Is that a lazy loader? Think back to the code that we did for the news analysis. Are those lazy loaders? Let me know. Let me know what you think in the chat. Okay, so Manoj says, I agree with Yassine. Yeah, I think Yassine gave a great answer, right? In the Monte Carlo, there's no learning. Not all algorithms have a learning component to them, or a fit component, right? Because fit, learning, kind of the same thing. Training, fit, learning, training, kind of synonyms. But yeah, I think Yassine gave a great answer. AJ says, isn't choosing the right portfolio in the efficient frontier analysis also some kind of model filling? It is, but it's not whether you fit a model, it's how you fit a model. That's the difference. Did you fit it because you saved a model from previous training and other data that you picked up and some sort of fancy neural network? Right, because neural networks really aren't lazy loaders. Neural networks are usually fit, saved models, right? Did you do it that way? Or did you do it via a Monte Carlo at runtime? That's more of the fit that we're talking about here, AJ, okay? Okay, so Fabricio, welcome. I don't think you've joined us before. Welcome. I appreciate you stepping up. So remember, guys, the answer in the chat right now is, what about the news sentiment? Was that a lazy loader or not? So Fabricio says, yes, news are lazy loaders. Train the model. Okay. Yes, news are lazy loaders. Train the model. Fabrizio, I'm sorry, but it feels like you're giving me two conflicting answers there. Are you saying that news are lazy loaders to train the model? Fabrizio, I'm sorry, if you could please just provide a little bit more clarification. But overall, I think Fabrizio is on the right track. The way that we've approached the model so far in the sentiment analysis, we also looked at some word clouds, right? Try to get us a feel for the words in there. We've kind of taken a little bit of a lazy loader approach to it, right? Yassine says, I haven't seen the code yet, but from the sentiment analysis I come across, it is not a lazy loader. Yeah, you could also make that argument, right? Because we were using the name of the library skips me right now, but we were using a particular library to determine the that, weren't we? So give me just a second to bring that up. Where is that? Is that in news collection? Yeah, that's right. We were using the news API client to tell us the sentiment, right? So yeah. So that is an example of us. But see, here's the thing. We could consider it. Denelson says, I'm going to have to say yes because the news won't have to be retrieved as often. Denelson, help me understand that. Because when we're talking about this, it's not a data collection phase. It's more about the model building phase. That's really what we're talking about, right? We're talking more about the model building phase than we are data collection or anything else. How do you actually run your model? Is it saved? Are there weights attached to it? Or are you just doing it at runtime? Because the runtime part is what makes it the lazy loader, right? Starry Vibe says, I think it's not. So here's the real answer, guys. The real answer is to be determined. But my gut tells me that with that project, we are headed to a hybrid use of some components being lazy loaders and other components being fit saved models. Because it's very hard to do NLP without some sort of saved models, right? But we've also talked about how the sentiment analysis it's going to be like a mini model feeding a bigger model, right? So I think that initial portion where we say, here's the articles, tell us how many are positive, negative, neutral. That's a form of data collection in a way, because we're kind of enriching our data and our knowledge. But the way we're going about it is a little bit of a lazy loader type of way, right? Because we're doing the articles in batches, we're asking another API to do it for us, right? We didn't write the sentiment code ourselves, right? And then we know that we're going to use that as an input to something else, because those results alone are probably not going to lead to investment decisions, right? So that's why I wanted to highlight that one, because I think we're headed towards a hybrid there. Some of our aspects are going to be lazy loaders to feed other models, but then those to feed other models that we created, and we're going to create those with a fit function type of approach, which is not a lazy loader, right? But again, that's just me giving my gut feeling. We could go in another direction, that's okay. But I think it's an interesting direction that we're headed in there because of that hybrid approach. Yassine says, I don't know the structure of the model built, but I think it will learn how the news will impact our decision. Yes, Yassine, the second model will. But this mini model that just does the sentiment side, I think we can make the argument that that's a lazy loader. Because it's really almost like an enrichment phase, right? Fabricio says, so it's 50-50 lazy loader and yeah, Fabricio, I think we're headed towards something like that. Yeah, I think so. But we'll see, we'll see. So, you know what? That's a really good comment for us to segue into the next discussion. All right. This is probably going to be our final discussion of the day, but it's an important one. So, coming back to our technical touch point, right? We talked about what we've accomplished. We talked about what we need to do this week, and we did it, right? We did further exploration on the efficient frontier, which I'm really glad we did because I think we've had good discussion. I think all of us have learned something. I've learned something today, right? So that means we've scoped out 3 ideas. Here's the next item. Are there any roadblocks that need to be addressed or ones that are coming up? And remember that we're always guided by our methodology, right? So if I'm being honest, I'm feeling like we need to start making some decisions. I feel like we need to start moving along in the methodology side. So for next week, where I think we're headed, right? Or, again, the roadblocks that I see here, this bullet item here, the roadblocks is we can't have too many ideas. We have to make decisions on which direction we're headed. I think that's the answer, right? We have 3 distinct models, three distinct approaches. I'm not going to say models, approaches. But we need to start moving more into that model design. We had a great time talking about time series, but we know that evaluating models by eye, by the graphs, is not efficient. So we are nowhere near done with the code for that one, right? Today, I think we made a lot of progress, but one, we discovered that changing the data, changing parameters can have significant results on significant changes. Right? 2, we also discovered that, I think it was AJ that asked, well, how do we make buy and sell decisions? Well, I gave you 2 examples of that, right? You could be doing it on a daily basis and adjusting daily. Or you could just be saying, hey, you know what? I don't care what the mix is on a daily basis. Just don't make me any less money than this. Only send me alerts when the return is less than this. Those are 2 valid approaches, but 2 completely separate programming efforts, right? From a model building and deployment perspective, 2 completely separate efforts, right? And then we also learned that we might have to budget more time for that model. Lazy loaders are not fast, right? That's the downside to lazy loaders. It's runtime. So your capabilities are a function of your CPU processor, right? And I'm saying that because most lazy loaders are CPU. I think lazy loaders can be helped by GPU, but not nearly as much as other approaches, right? So we got to make some decisions here. And some of these decisions are practical from a, hey, we got to choose a model, to functional, right? What if your client also gave you performance metrics that can't be met by a lazy loader? Well, now you got to cut that option up and say that lazy loader looks great, but it doesn't meet the client specs. That happens, right? So these are the things that I see coming up. And these are the things that you should be getting from your leadership to say, hey, what do you think of this? Because we need to make a decision here, right? Fabrizio says time and space complexity of the code is important. Yeah, absolutely. Absolutely. And that's going to play into our decisions, right? So when I say, hey, we need to start making some decisions, we need to start mixing all of that. So yeah, lots of things for us to think about here. So I think that this makes a natural stopping point for us to go into next week's discussion. So I want you guys, between now and next week, I want you guys to think about that. What direction should we be going in? Next week, we're going to start off with rationale by everyone to choose a direction. You know, earlier this week in my live streams, I talked about that. Plant a flag. You have to have some conviction in your decisions for data science. You can't always be wishy-washy. Oh, maybe this, maybe that. We'll think about. You got to say, hey, this is the direction we're going in. We did our scoping. We did our data collection. This is where we think are the greatest possibilities for us to succeed. Lots of value in being able to do that, right? Lots of value in you being the leader behind that. You know, a lot of you ask me questions. How do I move up into leadership? This is where that starts. For you to be willing to say, hey, I like the explorations we did, but this is where I think we should go, and this is why. That's where leadership starts in data science, right? So think about that. Between now and next week, we have to make some decisions. Now, as I mentioned earlier, I need to also make some decisions just to help keep the series going, right? So I might influence and I might make the final decision because, you know, I know where the series is going in my head. But from a data science team perspective, from a process perspective, that's the next big thing in front of us. How do we make those decisions and say, yep, this is the deliverable we're headed toward? All right. So last call for questions, last call for any comments. But that's the way I see us progressing. I've really enjoyed today's sessions, by the way, because I think that we went through some scenarios that are really valuable, right? And I really want to commend the people who stepped up and said, hey, maybe I don't understand this a lot. Can you explain that? Or can we ask ChatGPT or whatever? Those are all very valuable things. You got to know your limits. You got to recognize that you are a data science team, and you have to recognize when you're being asked to function as a business team and you shouldn't, right? Because that's not our role. Our role is still to be a technical team, right? I'm really happy with the fact that we're at a stage now where we have 3 really good explorations, right? So by the way, if you guys want to get caught up, so that means that part 4 was when we looked at the news articles and sentiment 2 weeks ago. Part 5 last week is when we did a deep dive into the time series. And then part 6 today is where we did the deep dive into the efficient frontier. So really good place for us to look at that. Okay. Starry Vibe says, I've learned so much about the efficient frontier in this session, and I truly appreciate the explanation. Thank you. I appreciate that feedback, Starry Vibes, but remember, I'm not trying to teach that. I'm trying to teach the process of data science, right? The projects of data science. So I'm still happy you learned, but I'm a little concerned because I really, again, let me go back here. What I'm really teaching is this. That's my goal, because this is data science. Efficient frontier is not data science, right? So I appreciate the feedback, right? And I know you're smart. I know you're learning, but I'm not trying to teach quant finance. And I've told you guys, quant finance is boring. Have you met any quants? They're like boring people. Oh, like I don't want to teach that. I want to teach this, right? So I appreciate the feedback, right? But I'm really trying to teach data science. Herbicio says, I have a background in finance, but doing data science grad studies. I enjoy this. I enjoy this one. Keep it up. Cool. Thank you so much, Fabrizio. Keep on coming back. I think it's your first time. Fabrizio, on Sundays is when I do the tutorials, but during the rest of the week, I ask people, people come and they ask questions. They set the agenda for me. I take on all comers as far as different things they want to talk about. So feel free to keep on coming back. You saw a completely different type of live stream today, but you can see others when you come back. Okay. Lakshmi says, I'll have to go through it again, but got really good new perspectives. Good, Lakshmi. I'm glad. And I know you have some experience, so I'm glad that maybe give you a couple of different things. But yeah, the point here is to just kind of help people understand, data science side, right? Not necessarily the quant side of it. But yeah, glad you're here, Lakshmi. I'm gonna delete this message. That's an offensive picture. I'm sorry, but you're gonna have to change that picture. You have an offensive picture there. Yassine says, "Thank you, sir, for all your efforts." Yeah, thank you, my friend. Thanks for being here. Thanks for all your support, guys. I think we had some really good discussion. Really appreciate all of you. I love the way this series is shaping up. Right, we're gonna move it along. Because, hey, you know what? We haven't talked about interpreting results, the viability of the actual solution. We have to talk about deployment. We have to talk about like the final delivery with the runtime. Like, what does the runtime of the model look like, right? This is all just exploration, right? We haven't even talked about the runtime, right? So, really, really glad the way this is going. Appreciate the good feedback. Appreciate your participation. So, as always, guys, lots of crazy things happening in the world. Please take care of yourselves, take care of your families, and I'll see you next time.